welcome back. Welcome to week 4 of Financial Mathematics for Actuaries. Today we are into lecture 16 which deals with annuity immediate. So far in previous weeks we have developed a context. We essentially dealt with all single sums and dealt with some 3-4 payment streams in a minimal manner, right? So what we have learnt so far in weeks 1 to 3 is if we have a single cash flow, we know how to effectively navigate from time 0 to time n. If we have, so basically we are calculating when we are navigating from time 0 to time n, we are calculating the future value. When we are navigating from time n to time 0, we are actually calculating the present value. Okay, and in between also you can navigate at some point which is j, which is between 0 and n. You can also navigate based on the notions of 0 and n. We have determined what is called focal date, right? And then we saw how we will revolve our calculations around that focal date using the equation of values. What we are going to do now is we will enter into a complex domain where we have streams of regular payments and we want to evaluate them in terms of present value or future value. So this relates to the real world problems such as mortgages, car loans, pension, your saving fund and all other stuff. So the math tool that is very important for this is geometric series. You have seen a glimpse of it in last week where we actually calculated some formulas for streams of 3 or 4 payments. However, this week we are trying to generalize it for n payments. So what are the goals for today's lectures? That brings me to the today's roadmap, which is we will define annuity immediate. After defining annuity immediate, it is very important to analyze the cash flows. Therefore, we have already seen, but we will ensure that you should be able to visualize the cash flow stream clearly. After visualizing the cash flow stream clearly, we will reveal this so-called immediate trap. Okay, once we have decided or resolved this immediate trap, then we will actually derive a present value formula which we have partially shown you. A teaser is already shown to you. It is called A angle N. Based on the interest rates, this formula will change. And once we have done that, then we will show how to master BA2 plus calculator, the calculator strokes, right? So all these things are related to our references, which are Browerman section 2.1, Chan and Say section 2.1. Okay, so now let us come to the concept of annuity. What exactly is annuity? Annuity is nothing but series of payments that are made at equal intervals. Okay, so for example, mortgage payments which are based on monthly intervals, pension checks that a pensioner will receive, those are based on monthly intervals. If you have some bond coupons which may be semi-annual, so essentially there is a series of payments. If you have some pension plan which is paying you on a monthly basis, if you have some insurance scheme which is paying you on a monthly basis, all those things are nothing but streams of payments that are made at equal intervals. So as you can see, this is a very important problem. Now when these payments will be made will determine what type of annuity it is. So there are commonly two types of annuities. First type is annuity immediate. So this is a trap. Annuity immediate, the payments are made at end of each period, immediately after the end of period. So annuity immediate says payments are made immediately at the end of each period. And the another one is annuity due. Payments are made at the beginning of each period. So, there is a difference and it is significant. So, I will describe this difference through visualization. Okay. So, let us visualize this difference let us visualize what annuity immediate is. When we will study annuity due, we will visualize that as well. So, what does annuity immediate mean? So, here is the series of payments. At the end of each period, we are supposed to pay. So, what is period 1? You can see the arrow mark there, which is actually the period 1. So, 0 denotes the start of this period and 1 denotes the end of period 1. Okay. So, when will you pay? Right, that is the question, right. So, payment, will it be starting at time point 0 because we are saying immediate? No, it does not mean the payment is now. Then when it is at the immediately after the end of period 1. It is like salary deposited in your account. Immediately after that period, you will get the salary. Immediately, once the period is complete, you will get. This is annuity immediate. So, series of payments that are made at the end, immediately at the end of period is annuity immediate. And once this is clear, then the cash flow is very clear. At the end of first period, at the end of second period, at the end of nth period, all these things will be given. So, the starting point is what the troubling part. The payment will start at the end of first period immediately. So, immediate does not mean now, immediate means immediately after the end of period, okay, once the period is complete. So, let us look at the present value at t equal to 0. So, when the payment is made, your present value at t equal to 0 will be, as usual, we already know something about it, and this if it is a unit value, then this with our notation, this is a V notation, right. So, you will have a present value to be V. Okay. So, this we have already noticed, and now I want to map all these payments to the present value. So, I have to use this V appropriately to give me whatever is the present value. So, once again I ensure that your annuity immediate is immediately after the end of period. Now, coming to the calculation of equation of value, where the present value for each of the streams of payments should be mapped to time 0, correct. So, V square, V cube, V raised to n, very clear, and this is a series of payments. So, all these things will be added up. Okay. Once this is clear, then it is just a matter of identifying what kind of series is this. So, this is a geometric series where first term is V, the common ratio between two successive terms is V, and how many terms are there? N terms are there. Do I know formula to sum this geometric series? Yes, I do know. It is A times 1 minus r raised to n upon 1 minus r. So, based on that, I will put these values, which is A is equal to V, R is equal to V. I get the formula for annuity immediate over n periods as V into 1 minus V raised to n upon 1 minus V. Okay. Now, let us simplify this formula, because everything is coming in terms of E, but what we are familiar with is the interest rate I, right. So, let us bring in that interest rate I and simplify this formula. So, the first trick is multiply by 1 plus I to the numerator and denominator. What you get? You simply get An is equal to V into 1 plus I into 1 minus V raised to n upon 1 minus V into 1 plus I. However, if you recollect, what is my V? My V actually is V actually is 1 upon 1 plus I. So, I will use this relation, and then you look at this particular number which is given here, it becomes 1. And then you can simply substitute the numerator with this particular transformation, and you get V into 1 plus I is equal to 1. Therefore, numerator is 1 minus V raised to n. Is there any other thing that I can do in the denominator? So, you know V is 1 upon 1 plus I. You know what is 1 minus V. So, 1 minus V into 1 plus I, we can split over it. So, it gives me 1 plus I minus V times 1 plus I, but this number, as you have already seen, is 1. So, this gives me 1 plus I minus 1, which will give me I. So, my denominator is I, numerator is 1 minus V raised to n. So, the annuity immediate formula simplifies down to an equal to 1 minus V raised to n upon I. This is a nice gold standard formula. Okay. Now comes how will I implement this formula through my calculator. So, that is what we will see next. We will simply demonstrate to you some of the buttons, key buttons in your calculator. So, I will bring in that calculator here. Just look at the calculator and what I am doing. So, now let us look at these calculations. First, you will see the second button, that is second. I have pressed the second button. Then I want to press this P by Y. Where it is? This P by Y is just above this I by Y. So, you can see P by Y is set to 1 for all annual problems. Okay. Then a very important function, which is this second, and then FV, just above FV is clear TVM. So, I will press that. So, it clears all my previous calculations. This is very important for us, because otherwise we may commit some mistakes. Okay. Now, I will introduce you to some key buttons on your computer. These 5 keys are very important for our calculations. First is the key of n, which is very important, and you can set any value and use that key. For example, if I want to set 5 value, then I will press n, then n is set to 5. Okay. Then you look at the other value, which is I by Y, which is interest rate per year or per period. So, let us say I want to set it to 5%, then I by Y is 5%. Okay. Then you can actually give me the present value, whatever is the present value. Let us say I want to put that present value as 500. I can put that as a present value here. Okay. So, I have calculated that. Then I can tell you what should be the future value, and I say if the future value is 0, then if I want to add that future value, I will say this 0 and I will add it as a future value. And what do I don't know? What is the cash flow that is coming out? So, that I can easily compute using compute PMT. So, if the present value is 500, if the necessary period is entered for 5 years with 5% rate of interest, it is giving me a cash flow of 115.49 every time till the end of the period. Okay. So, this is how you will use this financial calculator keystrokes. We will solve some problems using this calculator, which will nail down the concepts on using the calculators. So, let us look at example 1. This is a car loan problem. We are looking at our financial condition and we are deciding to take a car loan. So, what we have seen is at every year, at the end of every year, I may have $5,000 at my disposal and I can pay $5,000 for next 4 years. Okay. And we have also inquired with the bank. The bank, if I take a loan, will charge me the rate of interest as 6%. Now, we have to take a call on how much should we borrow from the bank if we are able to pay back this much. That means we are asking for the present value of stream of 5,000 which is given in 4 installments. Great. So now recollect our present value calculation. It was like PV is equal to V plus V square plus V cube and V raised to 4, right. So these are the 4 payments where we are assuming that we are paying $1 each time, right. So that's how we came up with the formula for our annuity 4 angle with 6% rate of interest, where my V is nothing but 1 upon 1 plus I, and therefore my V is actually 1.06 inverse. So this should be very clear in my mind, and then when I put this A4 or 6%, it will be 1 minus V raised to n, where n is 4%. So it will be V raised to 4 upon I, and that we call as this A4 6%. So this is nothing but 1 minus 1.06 inverse raised to 4, so minus 4 upon 0.06, okay, and whatever that answer comes should be my answer. But we have not yet related these $5,000, right. So how will I relate? So essentially my present value will be stream of 5,000, right. So it will be present value equal to 5,000 into A for 6%. Okay. So this will be my formula, and then I will simply multiply this A46 by 5,000 to get the answer. So let us do it here. So my present value is 5,000, A46% is this. You simply substitute it, and then you do the algebra using calculator, and you get the answer to be 17,325.53. Now let us try this problem with our calculator. So whenever you are starting with calculator, first thing is you have to clear this. Okay. So all operations are clear. What is the information given to me? I can afford to pay $5,000 at end of each year for a period of 4 years, right. For a period of 4 years, and bank is giving me 6% interest rate. So all these information, all these pieces of information should be entered into this. So let us say first I enter n is equal to 4. I have entered that. What we are essentially willing to calculate is present value. Okay. So what will be the cash flow that will be going from my pocket? It's 5,000, right. So that is 5,000 rupees which will be moving away from my side, and that I will enter into PMT. So this is very clear. Then I have to enter the interest that I will bank will charge me, that is 6%. Okay. So all the information, did I feed in all the information? Yes. 5,000, 6%, number of years 4. Then you go for compute and call for present value. You can see the exact matching answer 17,325.53, which is here, right. So this is how you will solve using your calculator. Now it's your time to give an attempt. Here is your challenge. Investment offers to pay $1,000 to you at the end of each period for 10 years. The interest rate is 5%. You have to calculate the present value. Pause the video, try using calculator, and on the other end of this video, I will solve the problem. Okay, welcome back. I hope you must have got the answer and you must have been amazed with the answer. So it's a simple calculation. Just look at this. This is 1000 into A 10 5%. So you can easily do that, and the answer is 7721.73. There are 10 payments of $1000. If you sum them up, it will be 10,000. But what you need to invest is 7721. Why is this less than 10,000? Because it's compounding. Money earns money for itself. That is where this is the beauty of investing. So let us look at what exactly is happening. Let us say at the end of period 1, I want to get $1000. How much should I invest at time 0? The answer is $952 for 5% rate of interest. You can check for yourself. Now you fast forward this in the time lane and go to time step 10. If you want to get $1000 in the 10th year, how much do you need to invest? The answer is only $614. And what we are looking at is sum of all these values, which actually turns out to be 7721.73. So the payment at year 10 is worth significantly less today due to discounting. That's the key takeaway. So here we have solved a wonderful problem where we see the power of compounding and the power of discounting when we discount it to the present value. Now here the present value was unknown. Let us look at when we have the future value and present value and the time n is unknown. So that's the next problem where I have $10,000 at present and we want to withdraw $1,000 every year. Interest rate is 5%. How long my money will last, right? So it's very easy. Again, you have to apply the same principle. 1000 is the cash flow stream, which I don't know how long will it last. So it's a unknown time problem. So let us put everything in place. So first is 10,000 equal to, you have 1000, and then you know the formula for AN. So in this case AN, this N is unknown, but the interest rate is known, 5%. So how will you proceed? So you will use this 5% known thing and you will say this is 1 minus 1.05 raised to minus n, this n is unknown, upon I, which is 0.05. Okay. Then it's just a matter of solving the problem. So you just take this zeros off, 1000, 10,000, 10 is equal to this, which you can reduce by, because of this 0.05 you can reduce, and if you solve this together will give you something like 0.5 is equal to 1 minus 1.05 raised to minus n. Okay, and that again you take this 0.5 on the other side, you get 1.05 raised to minus n is equal to 0.5. And then because n is in the exponent, we have already dealt with such situation. The natural logarithm is the tool that we will deploy and we will take it on a linear scale. So you got minus n ln of 1.05 is equal to ln of 0.5, and then you can simply use your calculator or whatever method you are familiar with. You will get n approximately equal to 14.2 years. Okay, so this is how you will do the math. Okay, so I will demonstrate that math. Whatever I did, just printed form. So this is 14.2 years. That means I will get 14 payments of $1,000. I will withdraw 14 times $1,000 and a partial sum will be given to me. Okay, so that's the final withdrawal. Okay, can I solve this problem using my calculator? Answer is yes. So first thing, whenever you start calculation, you just use second clear TVM. all calculations should be clear. What is the present value? You have 10,000, right? So you just feed in that value 10,000 here. This is my present value. What is the cash that is going out from this? It's minus 1,000. So I will write 1,000 and I will take a minus sign. I will put it in PMT, correct? Do I know what is the interest rate? Yes, I do know what is the interest rate. It's 5%. So I will put 5. I will put I by y to be 5%. What I want to calculate? I want to calculate n, right? So I will say compute and I will say n, correct. So it's 14.21. So we have again shown how calculator can be very effective for solving such problems. Okay, coming back to our next slide, where calculator will be of significant help, where we will solve for an unknown interest rate I. So let us solve for interest rate I, where the loan amount is 5,000, payments are 1,000 for period of 6 years. Then if the payment loan amount and interest is getting paid off in 6 years, what should be the interest rate I? That is the question. Very simple. Again the same formula I will use. 5,000 equal to 1,000 times annuity 6 I is unknown. Instead of n, now I is unknown. So essentially it reduces to a 6I being equal to 5, correct. So you just solve this using math. You have 5 equal to 1 minus 1 plus I raised to minus 6 upon I. Can you solve it? You can do some algebraic tricks, but you may not be able to solve it. However, you can solve it using our calculator in a very easy way. So again, I will go back to the calculator. First step is clear the previous work. Everything is cleared. What is 5,000? It's a loan amount. So that is our present value. So you just feed in that present value 5,000 in your present value. Okay. Next, what is given to you? The interest rate is unknown. The time period is known to you. That is 6 is your n. And what else is known to you? The cash flow. $1,000 are going for 6 years. So you just push in 1,000 and negate it because it's a money going out, and it's put it in PMT. What I need to compute? I need to compute interest rate. So press compute, press I by y. 5.47 is the interest rate. Let us see what we get here. Okay, 5.47 is the interest rate, and this is the sequence of calculations that I have already shown to you. N 6, present value 5,000, cash flow minus 1,000, and you compute I by y, you get 5.47. Wonderful. So what we have is a nice tool, and with calculator you can easily solve all these annuities problem. So far whatever we have done is we are looking at the present value. What if I decide to look at the future value? How will the calculations change? The answer is very simple. If I decide to look at the future value, instead of t equal to 0, I have to look at t is equal to n. Okay, and the use cases when we look at the present value are loans and mortgages, which we have seen. If you look at t is equal to n, where you will actually earn the money, it's savings or retirements. Okay, and in these cases, what are the formulas that will help us? An, you have 1 minus v raised to n upon I. This future value we have shown you in the glimpse, and that is 1 plus I raised to n minus 1 upon I. And the golden link between these two, your future value is Sn equal to An times the interest accrued over n periods. So 1 plus I raised to n. Okay. So, that is the golden link that we have. Therefore, what we have done today is, it's time to summarize what we have done today. Let us summarize. First, we understood what is annuity immediate. So, payments are made at end of each period, immediately at the end of each period. So, T is equal to 1, 2 and so on up to n. We looked at the key formula, which is PV is equal to the cash flows, that fixed cash flows that we are, that those are called PMTs, into 1 minus V raised to n upon I. When you are using calculator, you always see, you must have observed this, I am entering present value with a positive sign and the cash flows with a negative sign. So, PMT was always entered with a negative sign. Next, we will look at the second kind of annuity, which is annuity due, where the payment is made at the beginning of the period. So, payments are made at the start. How will our calculations change, and what are the use cases for this? If you are buying insurance policy, you have to pay upfront. If you are taking a house on a rent, you have to pay upfront. So, all these are use cases of annuity due. We will see you in the next class with more mechanics for handling annuity due. Thank you for listening.